Hello, my name is Nurul Zaman and I will be presenting Cassandra is a real-time column-oriented database. So Cassandra is one of the leading NoSQL databases that have gained popularity over the last few years. So I'll gloss over some concepts before we dive into implementation. So in the next couple of slides, I have the concepts and the motivation for Cassandra. It's a fairly sophisticated database, and I have some more information in my report, or of course, you can always Google it. Very strong on data partitioning and fault tolerance, and very sophisticated failover mechanism. But we'll jump straight ahead to the data modeling part of it, because our implementation is mostly derived out of it. So the data model for Cassandra is very different from relational databases. So the basic unit of data is a name value pair, which is referred to as a column. So for example, over here, text is the name and hello world is the value, sender is the name, 123 is the value, user is the name, 99 is the value. All these columns strung together create a column family. And this column family, for this column family, this row is identified by a row key. And then the next one is another row. But here, for the same column family. But here you see that there is one more column which is different from the first one. The first one doesn't have this in reply column. And that is fairly normal because in Cassandra you can have a number of different columns in the same column family. And it is entirely possible that the first row has 3 columns and the second row has 3000 columns. So now we'll just go ahead and install Cassandra. You download Cassandra from Apache site, save and unpack it in your directory, cd to the bin directory and run Cassandra. And and I know that I have to use sudo to run this for some reason. You probably don't have to. And I am using manSF so that it runs in the foreground. And it flies by, it shows a lot of messages, and now it's listening. So that's it. It's pretty much up and running and listening for clients. We'll move it out of our way for right now. So based on what we learned about data model in Cassandra, we'll design our cache for order management system. And what it will do is, so order management system itself allows buyers to look at their purchase history and see the orders that they have placed over time. And when viewing the purchase history, the buyer can choose to look at all orders against a seller or choose to look at all orders with a given status. Purchase history can contain large number of orders, and to retrieve each order, we look up data from multiple sources. So instead of looking up all orders every time, we'll save the retrieve order in Cassandra cache and serve data from the cache. So that is our model. We'll get all the orders, we'll save it in our cache, and then we will generate a denormalized model which will save all the orders against a given seller in one column family and all the orders against a status in another column family. So we have already defined our database design, and we'll use a command line interface from Cassandra to create the database and add an order. And then we'll go through some other options to create the same database design. So let's grab the same window shell again. And here we can see it's still running the Cassandra database. And we'll switch to Cassandra shell. Now I'll just try to copy and paste all the commands from here. So nothing to drop actually. Create the key space. And now we'll use the key space that we have created. And let's try to create the column families. And so on and on. We can use some of the commands. Help, and then show schema will show us what we have created. So we have created the column family order summary, we have created the column family order, and so on and on. And we can add an order by just copying this. And the order is there, and it requires a semicolon. And we can retrieve that order by saying get order. So it's not like a traditional SQL language in this client. It's more or less Java get and set commands. And here is the order, buyer ID, order date, order ID, timestamp. Timestamps is built in into Cassandra. And so it's telling me that the order that I saved for this buyer, the buyer ID. So this is the row ID. Is this CLIB1, and it's showing me all the different attributes that I added for this particular order. So this is not the only client that Cassandra has. It has another client which is more or less geared towards the SQL, and supposedly this is the one that they are asking people to use now. So it's pretty much the same thing, drop key space, create key space, and it will do the same thing that we did with the other client. And you can run it, just copy and paste it on the client screen. First you have to go to the SQL shell, and then you can just run all these commands and they should work as they're typed in. Now we'll be setting up Cassandra Java Hector client. So the Hector libraries are one of the most commonly used Java libraries for Cassandra. We'll also be using JSON libraries from Google because we'll be converting the order objects into JSON format. So these are the libraries, the JSON libraries and the Hector core libraries. And what I have done is I have taken those libraries and I have dumped it into the Cassandra libraries, which will be pretty much we'll be using all linking all of them in our Eclipse project. So I just wanted to keep them in one place. And we'll take our Eclipse and we'll just import the project. archive file, Cassandra demo, line, and let's see. So our code is all loaded right now. So there are a couple of files that we want to look at. So one of them is the OMS schema creator. So this is kind of like the same thing that we did in the command line interface. The same thing we'll be doing with the schema creator. So this is like common method: get key space, get cluster, create column families, order details, summary, and then there is the method recreate, which recreates this schema from scratch. And we have a test for it, and we can run this test and it will just recreate the schema. We'll just run it and it will just recreate the schema. See, removed key space and recreated the key space, created column families. Then once the schema is created, we want to populate it. So I use something called a controller. So this order management system controller. And in the controller, we have the different method in the detail order, the summary order by seller, summary order by status. And then we have this big method called create cache. So what it does, it takes a bunch of orders and then it just divides them up into split by status or split by seller, and then adds them to the Cassandra database. So for our queries, we know that the buyer will be looking by seller, or the buyer might be looking by different statuses. So we'll create all those tables or column families. And this is the column. We don't need this. We can see create for group by status. And we can run this test. And it's telling me it inserted all those values in the database. I also have something called an OMS client, which is just a small utility, text-oriented utility that I created. And it has the same thing. It recreates all the schema, it populates the cache, shows the details, show order summary. So let's try recreating all the schema. So, and it recreated all the schema. And then we say populate the cache, and it populated the cache with all the data. And if you want to say show all order detail, it will show me all the orders. And I can say show summary by status. So right now it's hardwired to paid, so it will show me all the paid orders. So and here are the paid orders. Back to menu and exit. And so this is my little demo about Cassandra. There are some challenges with Cassandra. It's good for some use cases where data is unstructured and the queries do not change very often. And it takes some time to get used to the denormalization part of Cassandra. And you have to generate a lot of code because database design is now part of the code. If using a schema which is less structured, it will be tough to figure out how to query the data. And in closing, thank you all for a wonderful experience. And thank you, Professor, for offering this course. Thank you, Professor, for tinkering with the code like a real developer. Thank you, TS, for your explanations. Thank you, my fellow students, for being so helpful. Yes, thank you all. It was great.